So welcome to the system design on Thursday. Last time we were talking about the design of the chat system. And we were talking about the database design and in general how the whole system looks like. And this time we have several leftover we want to talk. And especially, I can't really remember all the topic we want to talk. Maybe you guys can remind me. And but I know that we want to, at least there are some things like a notification that how if user send a message to the group to another person, how that person or the member of the group can receive this message, how to design this part. And another topic is that timing issue. So we may have multiple machines to receive the message, and so each of them may have their own time. So how can they how can we make sure the order of the chat is in correct order? So that's the thing I want to talk. So and just like before, I would like call for some volunteer to start this topic. Is there anyone interested in design this part of the system? Anyone want to try this out?
So we are just designing this notification system, and
yeah, notification is one of them. And if we find something else, we can talk about some topic. Do you want to try?
okay, sure, yeah.
Okay.
Okay.
And at zero, I would put the whiteboard and the coder pad into the Zoom chat.
Okay, sure, yeah.
So, yeah, you can see that, you can use that.
Notification time, okay. So I'll share my screen. Can you guys see?
I can see your screen, your coder pad.
Okay, and you can see the whiteboard.
Yeah.
Okay, so we are building. So basically, this notification system would be on a topic itself that we want to design a notification service. So
yeah,
and so how did we decide to store the messages? I dropped off like in the last 15-20 minutes. So how did we?
Yeah, I would say that we already have the system. We already have the database design. So in the system, we may have some missing API to say that when we have new message, we want to call part of the service or some microservice to say that I want to notify this user, a list of users. And if they're online, I would like to send them a message.
Yeah. Okay. So yeah. So basically, like the thing which comes to my mind whenever building a notification system is a queue that you will push the messages in the queue. So the producer will push the messages in the queue, and your clients will be the consumer, which will consume those notifications. And once those notifications are consumed, those are deleted from the queue, right? So yeah, so basically, so let's say we have, I don't know if we care about the, so if we use these existing queue services, Kafka and all, they take care of ordering of messages and persisting the messages. So the problem which I see is that, I mean, let's say if I'm sending a message to someone and that person was offline for 1 month, right? Then when he comes back online, should he be receiving the notification then or not?
I don't think it's necessary because he can never be online. So some user may be dead. I'm not sure that the dead may be not the right word, but never log back. So there could be some broadcasting, like we have a big group and some of the group member may never go back online. So in that case, maybe the user go back to the service after a month. So it's the user's app's responsibility to call for the server that do you have any new do you have any new message or not.
Mm-hmm.
So we only notify the people online, people who have still have the app open and their phone open.
So yeah, and I was thinking, so this queue, so producer will push the messages, and then consumer will pull the messages, or yeah, I think consumer will pull the messages, right? Instead of, but with notification, or is the queue going to send notification to the consumers that hey, there is a message, and notify the clients about that message? These two are different. One is the clients are polling the queue, and another model is that the queue is pushing notification to the clients. The in both the cases, like if the client is offline. So I think if the client is offline, so let's say if we have a push model where the queue is pushing notification, then if some client is offline, then the queue will keep on retrying after. So like it will keep on retrying every 2 or 3 minutes. It will keep on retrying until the client is online. And I think, yeah, but the problem is if the client is dead or something, how will, like up till what point it will keep on retrying, right? That's a
So
question.
what's the client here? Is the phone or
Mm-hmm.
something different? You mean the phone? The phone need to
Yeah, the phone,
subscribe the queue?
yeah, the phone, the app, yeah, the user.
Yeah, it seems like the phone need to keep a connection with the server constantly.
Okay, right. Okay, so yeah, okay. So basically, when the client will come online, it will establish a connection, right? And only those clients which are online, which have an established connection, they will be getting the notifications, right? So the first step is that you have to establish a connection. Like there will be some state which says whether this client is online or not, right?
Yeah.
Or is there any other approach which could be better?
We don't have we don't know yeah, if the online, the user may get may have the app open, but remember that when we use any chat application like WhatsApp or whatever you guys are using, we know that even though we close the app, we can still get the message. So get a short notification that you have new message or what's the summary of this message.
Hmm.
Yeah,
So
this
yeah,
is, you go
so
ahead.
yeah, you're right. So no, I'm saying so then in that case there is a connection established between the client and the
Mm.
and our server, right? That it is still online. Like otherwise, how would the server know that?
So the server here is the notification server or the web server which is processing the message?
Yeah, the web server, the queue is a server over here, right? The queue is the server, and the client is are these mobile apps. Okay, let me draw something. So this is our queue, right? And these are our clients. And this
So this notification system is in connection with the chat application, like chat system, which we discussed last time, right?
yeah, yeah.
What I was saying, like let's say like a client A send a message, so that message will be processed by one web server, right? So that web server will do the processing and will store the message in storage, and will if that client B is online, it will send that message to the client B as well. So we are saying like that client B will have a web connection with that web server, or there is a notification service different. The queue will be part of that notification system. I'm just trying to understand the design here.
So yeah, like it could, yeah. I think there would be these two systems which are connected, but they are in a way separate. So uh, basically, all your messages are stored in the database for persistence, right? Or when you want to get history and all, your messages are stored in this database. So whenever you send a message, so whenever A sends a message to B, that is first stored in this database, and I think all those things which have been discussed. But then this message is also pushed into this queue, right? And so now this message is pushed into the queue. So let's say this message A sent to B, it's in the queue. Now B, so, and this message is aimed towards B. So we have to send this notification to B, right? So this is our overall design. We have to send this notification. So now the question here is that this queue should know that this B, like there should be some connection established between this queue and B, so that they know they have to send the notification. So now what you're saying is whether this connection is established between the web server or the queue, it could be like, I think because it is being dealt by this notification system, so it will be the responsibility of this notification system which will establish the connection, and it is responsible for sending those notifications. But yeah, so this, there should be some connection established over here to know that this client is online and I have to send a notification to this.
Okay, okay. So because
Yeah,
I
I
was,
think.
sorry, go
Uh,
ahead.
Go ahead.
I was thinking like we can have a cache, and in the cache we can store user ID and timestamp. And like every time you can look up in the cache if the timestamp is recent, then it will be that the user is online. And basically, if the user is in the cache, that means the user is online. I mean, you will have to keep updating that cache. So I don't know if
But if you will use the cache, if the user is offline and your cache is stale,
yeah,
what?
so yeah, you need to I mean, I have a service like we do something similar, like you keep on checking the status and you maintain a cache, and there you actually in the cache you keep on updating that status. So basically you'll keep on updating timestamp here. So if the timestamp is one of the recent, that means user is online.
Okay, like
I'm
my
not very sure about the solution, but I was thinking it like it
my
kind of
understanding is like
related. Yeah.
cache is something which you can use to like to get reliable information, which is repeatable, right? Repeatedly you want to get some information, but that information is correct. Here you repeatedly want whether the client is online or not, but that information might not be correct. So
Yeah, we don't want it very accurate. By the way, I post a document from Apple. That is how the Apple handles notification. Yeah, I roughly read this document and see that Apple have some long-time connection between the iPhone itself and to some server, so they know that which iPhone the service can push the message to.
yeah, exactly.
Yeah, so there I was having same thought, like, because when this web servers, because this is a real-time messaging system we discussed last time, right? So the web servers would have the like WebSocket connections with the clients which are online. So if the web server itself have a connection directly with the client, like, why can't the servers itself send the notification? Like, do we like need another service? If yes, like, I'm curious to know, like, what are the pros and cons of
So okay, yeah. So the point is, okay, you have your server, uh, which is looking at the connection, that if it is connected or not, and if it is connected, it will deliver the message. Very good. But what if the client is offline? Then somewhere you should know, right, that this message still needs to be notified.
But I think Iran said in the initial, like, we don't want to send notification if the client is offline, or
No,
we.
after let's say my connection was sloppy, I was traveling. After 15 minutes, I got the connection. So still, I want the notification, right? And also, like, uh, so I mean, see, database is for the persistent storage, right? You will always keep the message. The difference with notification is, you once that notification is delivered, then you have to delete that notification, because now you have notified it. So basically you need this another kind of storage where you are keeping the messages that you have to send, but once you have sent those messages, you are done with those messages, and you can remove them.
Okay, so do we need to define like a window, like, I will send notification only for the last X days? Because let's say if I never logged in the last 30 days. So after 30th day when I come online, I will get notification for all, or there will be some last X days of notification?
I feel like notification, if the iPhone itself is not online, it's out of the network, I think in this scenario, the notification should be discarded, because
So
there should be a lot of notification, and if the app start again, like if after a long travel, the app itself should get any accumulated thing from the server.
yeah, okay, yeah, that makes sense. So what we're saying is, so we will try to establish the connection, and if the connection is established, we will send the message. If not, we will retry, and we will retry for like some X amount of days or time. If the client is not online, then we will mark this message as expired or deleted, and then we can remove the message, because anyways user data is not lost. It was persisted in the database. This was just notification service. So when the client comes back online after this many days, he can still see the messages, only he will just lose the notification. It should be fine, right?
Yeah, I agree.
Yeah,
That
so
this message should be something like the UDP, and it can reach the destination or it may not. So the notification is not really important.
I think it will be TCP. So basically, uh, when the client is online, the message has to be sent reliably, right? So I think all the text messages are generally sent as TCP, because they should be sent reliably. Uh, because if the client is online and if we are not sending the message reliably, that's the problem. So in UDP, uh, your some part of the messages, some packets can get dropped, and it's okay, right? So like in videos and audio, if I'm talking to you in audio, if that some piece of my voice is dropped, it's okay, and it will it will not retry, it will continue, because what I'm speaking now is more important than that missed part which has to be delivered. Similarly in video streaming and all, if that moment of message was lost, it's okay. But whenever we are sending this textual content, I think we have to use TCP. This is what my understanding is. I don't know, what do you guys think?
Actually, I have a different question other than this.
Mhm.
Just trying to understand this notification queue. So let's say like if the, but yeah, like I have a different question, but yeah, I will ask once the previous discussion is done.
No, yeah, I think no one has anything to say on that, so probably you can continue. Yeah.
Okay, so my question was like, let's say that B client was offline for 15 minutes. So after 15, and let's say that B client has X messages in the queue.
Mm.
So like when the B client will come, it will see like I have 15 messages or 15 notifications, right? So will this notification service will do cumulative when the B client will come online, or it will like it will wait, like when the client will come, it will just shoot all the messages? Like I'm just trying to understand how this queue service would work.
Yeah. Okay. So yeah, that's a good point. So you're saying if there are 15 messages, is your question that should we deliver 15 messages in that one notification, or there will be 15 notifications? Is that your question, or?
Yes, 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 yeah. Like when the client will come online, will there will be 15 messages to like 15 notifications to a client B, or it will be like since Q already know like I have 15 for B, so it will do a cumulative and send in one go.
Yeah, I think that's a good question. I think it depends on the system design. From the system's perspective, we can do both, right? We can, the queue will look into the 15 messages, and it can, but if we will combine those messages, then we need some additional processing to be done, right? So that combination logic, how to combine them. And in some, for some kind of messages, that combination might make sense, but for some it might not. Like, I mean, if I was talking to few different people, so I don't know how I would be able to combine those messages, right?
Yeah, right, right.
I can either say just, hey, you have got 15 new messages. If that's the combination strategy, yeah, that works. But if I have to show them messages, then I think would have to show them independently. I don't know how we can combine them. And I think that's what happened in our phones, right? We get multiple notifications when we come online, and that's why our phone would like be in constant ringing phase when sometimes when we go from offline to online, right?
Right, right, right. Makes sense. So you're saying like we'll have 15 messages. Okay.
Mm. Yeah, I think we would have to send 15 notifications. Yeah. Mm.
I think this can be seen from a uh, different angle. That if in a scenario that the client will receive multiple notifications because the client didn't receive the first notification for some reason, maybe it's slow to respond. And if they're slow to respond, I think the client should discard, sorry, not the client, the server should um, maybe try one or twice to send a message if it's still failing, we can say that the client may not reach the network. Because of that, they cannot send send the first notification. So there's only second notification in the system. Oh, yeah, I'm also trying to see that what if, yeah, there could be some really tricky thing that the client may reach the network, and in this scenario, the client may get a notification that the third message is arriving. But actually there are two more which are discarded. So yeah, this can be a very tricky thing. I don't know how to answer that.
What's the problem you're saying? So, okay, so there are two different things here. One thing is, let's say we are keeping only 15 minutes of messages, right? So one problem is if all are up till 15 minutes, we have accumulated some messages, and before our deadline where we were going to expire the messages, the client came online. So now we have to deliver all 15 messages, right? Because we were saying that up till 15 minutes, we will keep the message. So that is one problem which we were discussing. So now these 15 messages, do we combine them or do we send a separate notification? The other thing I think which you're talking about is, so now some messages are past the deadline and they have expired, right? So now if they have expired and they have been dropped, and now if you will send notification only to about the newer messages which are in that past 15 minutes of window, I think that should be okay, right? Because those are your recent messages. So generally you get notification only about the recent thing. So even if those messages are dropped from notification, if you will open my chat, if you will open me and your chat, you can see the messages that were not delivered as part of notification, but they were being pulled up from this original database. You will see the messages, only you will not see the notification, right? So
yeah, we can also make the notification as simple as just a flag to say that let the client to check the message. So it doesn't matter how many messages we receive, it just get only if I get the most recent message say that please check the message, and the client may reach the server to pull out the latest one, nearer than the token.
I think that's a good point, and I think they generally, I don't know if they do this at this here in the application code or at the server level, that basically if there are 15 notification, then instead of bombarding with 15 notification, it can combine and say that, hey, you have 15 new messages. So at each user level, either you can combine that you have 15 messages from this user, and then when you click and go on to the app, you can see those messages which are being pulled from the database. So yeah.
Also, I wonder that if this is a queue system and the client may need to subscribe the queue, and I remember that we see that Apple will keep a long connection with the server. So that service can be just for the notification service and it can accept different applications. I think that in that case, the Apples or maybe other phones, client may have some infrastructure to subscribe the notification system for the phone itself, not for the app. Then it will receive the notification for different apps to show different things. Yeah, but in this case, I think the queue makes sense.
Yeah. Okay. Yeah. So I mean, is there anything I missed, or do we need to discuss anything else here? I oversimplified it. I don't know if there are other issues over here.
I think that's good. I can't think of anything. Anyone else to have any?
I mean, I have made it easy by like giving all the responsibilities to this queue, that this queue will be responsible for, like uh, deleting the messages once they have been delivered, and like persisting the messages for those 15 minutes if the client is offline. So all that responsibility I have given to the queue, so which has just simplified the design, that you just use this queue service, Kafka or whatever, and it will take care of it.
I'm not sure about all the other queues, but the Kafka, I think that needs this scenario very well, because Kafka have the, my impression, the Kafka's queue is different from the something Rabbit queue, that there's the client don't have the responsibility to delete item, because the item will expire after like 7 days. And they can the items, the queue items in the Kafka's queue can even be deleted before the client gets that, because the client may subscribe the process. Actually, it process the queue item for a really long time, and you can now see the new message, because the Kafka client will subscribe the queue only. It only gets some index, some offset on the queue itself, and it keep moving, and it will not delete items. So, so it can handle the thing that's not very important.
Yeah. Right. So like, are you saying in case of Kafka, the client will have to pull the data from the queue, right? And they should know that what is the last index up till which it has read the data. Is that what you're saying?
I think Kafka's the server have keep some record. I don't know. I need to check.
Yeah.
But yeah, the subscription just have the offset and read the data at its position.
Okay. Yeah.
Yeah.
Okay. So should we move on to the second part, which was
timing,
the ordering?
Yeah.
Is there anything? Okay.
Anyone have any other comments? Okay, I guess we don't have.
So yeah, I just have one thing, like before we move to timing, can we have like a full like a design, like from like how from if A has to send message to B, how the end to end will look like? Just to recap of the entire design. Or we can move, we can move to order issue as well.
Yeah, I mean, we can probably I think we can discuss the ordering thing in, I think, next 15-20 minutes, and then then we can discuss the overall design. So remind me, what's the problem with the ordering?
The ordering is that remember that we have this issue that if A and B send the message to the server, how we can keep the order out of message.
So if so the problem is A and B are sending the message to whom? Are they sending it to each other, or are they sending it to a group, or what?
So send it to a group chat.
Okay. So yeah, so it's not a problem. So if there is a group chat, right? I think we are done with this. So let's delete this. Okay. So now we are saying that this is my group chat, this is A, and this is B, right? And so up till now, I have a chat from C, I have some chat from D, right? And now A and B. So A and B can also see this in their system, that the last message was sent by D, right? Now A and B both decide to send the message at the same time, right? And now you're saying how will we order their messages? Is that the question?
Yeah, so they send the message almost at the same time.
Same time, yeah. So there is no problem. I think, yeah, it's the choice of the server. It can choose whatever message it thinks it got first, and then it can then deliver that. So let's say I thought that the server thought that the A delivered the message first. Then I will show A here first and B here first. Or if the server thought that the B delivered message first, A delivered next, that is also okay, because when A and B were sending the message, they both have seen messages till D, right? Are there any other colors here? I don't know. Okay. So they have both seen the messages up till here. So they will never complain that why did my message came before his, because they both have not seen each other messages, right? Do we understand this?
Can you, um,
So,
what do you
okay.
mean?
So my question is, if my service, if I show A first, B first, or if I show B first, A first, what's the problem? Who will complain? What am I doing wrong?
I think nobody may complain.
Yeah, because nobody has seen each other messages, right? They both were sent concurrently. So if they both were sent concurrently, then it's okay. Like I can process any one of them first because they were concurrent. So
Yeah, originally I was thinking another thing that um, for each server that I send a message to the server 1 and B send the message to server 2, and there should be some consolidation process that they merge the message together. So I was thinking that maybe the server 1 and server 2 have some roughly synchronization with some time server and TP server. And when the message receives the server, it gets the timestamp. So anybody who want to read the message will pull the message, the whole message from the some service which have access to the database. So when they get the message itself, it already have the timestamps. So the message will be in order automatically. And so in this scenario, it is possible that A comes first, B comes later. But when we receive message B, we can only read the message from B, and because A for some reason is not escalated to the consolidation. So, but A can come later. So then we can have some very interesting thing that we get the message B say that I agree with you, and we don't know what it agrees, and A said my proposal is this, and B say I agree, something like that.
oh, yeah, can you just I'll stop. I want to understand your point properly. Can you just draw and show like how this problem will come?
Sure.
Yeah. So are you sharing? I think you can share the screen.
Sharing now.
Yeah.
Okay. Get my. Basically, there will be a timeline that say we have a timeline here, and there will be A and there will be B, and they have some server. Server can be in different position, and this is the time. And so A goes through the server, and it escalates. It gets the, so this is timestamp. This is real time, but it can reach the consolidated into the database like this timestamp, something later, and oh, maybe let's make it. So this can be a very long time of processing consolidation. So, and B may start talking at this point of time. So the real order can be here. This is real time, but the message will escalate into the database at this point. So at this moment, we can have the chat. So B says something. There's no A, and only one at this time. The other people will say that A trying to say something, and B try to agree with him. So this is the problem I'm talking about. Is it clear to you?
Uh, so one thing I'm not clear about is, so how did A see the B's message? Like how can, so you are saying A is saying that I agree, right? A happened after B. The message of A happened after B. Is that what happened?
Oh, I see your point, because A at this point don't see any message from B, so it can't agree with anything.
Kiki, can you
Yeah,
give an example? Okay, so let's say the, can we do this example? So someone is asking, how are you? And other is saying, I'm good, right? So I'm good should come after how are you? Or will this
that's
apply?
right.
Okay. So now let's take this example. And so who is saying, how are you? And who's saying, I'm good? Who is sending the message?
A is saying, how are you? And B is saying that I'm good.
Okay.
A at this time, and B at this time.
So, so what, so, so B is saying, I am good. B's message was delivered to the consolidations. So there are two different services we have. Like one is the database and another is the consolidation service. Is that what you're saying?
Yeah, DB will be in a separate service, and because A and B are in different locations, so we may have the server 1 and the server 2. They have the same service, same kind of service. Server A is close to A, so server 1 is close to A, and server 2 is close to B. And when the server 1 receives the message from A, it will put the timestamp on the message. And one is trying to talk to the DB, the connection is very slow. So you can see that the message A appears in the DB in a very late time.
So if the message appears in DB at very late time, how will B see this message? How are you? How does B knows that A has sent this message? How are you? When it appeared so late in the database, like he will only reply when he sees the message from A, right?
Yeah, I think that's a good point. In this case, it can be avoided. Yeah, maybe this is not a really good example. Yeah, never mind.
Yeah, I mean, I know there could be ordering issues, but if I could not think of that, how will we get the ordering issues?
If you're pulling the chart history, for example, and you have not maintained like of all the messages, then you will have problems, right? How will you know whether C send the message first or D or A or B?
Oh yeah, yeah. Okay, I think yeah, that's a good point. Okay, so the point here is when we are storing them in the database, right? If we are just using the timestamp of the servers, then we don't know the ordering of the messages, right? So we should know that the server timestamps are not correct and there should be some logical ordering. So we would not be using the ordering based on timestamp, but we should be using uh, logical ordering, right?
Yes.
Mm-hmm. Okay. Yeah. So then, yeah, I think with every message, we will also be sending this logical IDs that, so if B sends the message first, we will give him ID 1, right? Now when A is sending the message, he has to, in his request, he needs to send the message, my message, and he also needs to send what was the last message ID I saw. So the last message ID I saw was 1, right? So then my message has the preference of 2. It means that my message came after yours.
How can they, in this scenario, how to maintain the order? Because if there are two servers in different locations, how they won't know each other until they write to the DB.
Mm-hmm.
So how can they have the order in this scenario?
Okay, so let me try it out. Can I take
Sure.
control? Share. Okay, so I think the problem is, so let's say we have these two different servers, A and B, they're talking to each other. So A sent some message first, hi, how are you, right? And this is stored in this database. And this database time clock says, hi, how are you message is at 5 p.m. right? And so basically with the message, when this came, when I'm storing in the database, I'm taking the local, whatever is my database's local logical clock. Then I deliver this message to the client, B client, and B can see on his chat, hi, right? Looking at my message, he is replying, how are you, right? And now let's say I am now storing how are you in this database. And let's say this database timestamp is behind or something, and it is saying that this message came at 4:45 p.m., right?
Well,
So
how can they be different time? If they are, what's a big rectangle you're drawing that high and how? Are they
what?
different DB or they are
Yeah, so this, as you said, right, this is server 1, this is server 2, right? So this database, when it is storing the timestamp, it will use the uh, timestamp of server 1, right? And then
okay, this is something temporary in server 1 and not written into database, right?
if,
Because you
yeah, I
have
mean, so it depends, like how, yeah, I don't know what the database model we have chosen is. Are they going to be stored in the same database? But if they are going to be stored in different databases, like server 1 has one database, server 2 has different, then this problem will come. But if you are saying that B's message will also go to server 1, same database, then this problem will not occur, because then the time clock of the same machine will always be increasing. So then this will always come at 5.1. So now here it depends on your database design, what your database design is.
Yeah, I would say that we put all of them into a logical view of the same database. So they
So
may
by
have.
by same database, do you mean same machine, or like, or that logical database which is spread across multiple machines, which is a distributed database? So in this case, I'm saying it is same database, but it is distributed on multiple machines. So this part is storing the messages which are close to A. This part is storing the messages which are close to B, right? So probably it's that same database, but it is distributed among different machines, right? So now every database will use the timestamp of its machine, right? Its server. Like I cannot take that timestamp from A because A is a client. It can send me any wrong value or something. I have to use my local timestamp, right? And my local timestamp can be off. Like the server one might be a little bit ahead than server two in actuality. So those problems can happen. I have exaggerated the problem, but it could happen that this sees 5 p.m., this sees 4:49 point like 55 or something.
How can the 5 p.m. and 4:45 p.m. here is part of the data, so they cannot be different if the database, logical database is the same. Even though they are in different nodes, but they should store the exact same data.
Is time
Yeah,
like,
I think
so
someone is saying something. Yeah.
I was saying like maybe the time issue can happen on the web server, like the web server, like server one who got the request from client A has different time logical clock as compared to another web server which is serving request B. Like,
That is very likely for very small amount of time, but time can be, yeah, each server may have slightly different time.
Yeah. And so we call it physical timestamp, right? Logical is like logically what you are ordering the events and doing the right ordering. I think that is called logical timestamp, right? So this 5 p.m. is like actual timestamp, physical timestamp, right? So like I'll give an example. So now how this problem can be solved by a logical timestamp, logical thing. So I'm saying that I have not seen any message before. So when it will say that the last message I have seen is 0, right? So now when it will send hi, it will send 0. That the last message I saw was 0. Its timestamp, logical timestamp was 0. So then in this logical column, I will store, so the last was 0, so its value is 1. So logically it came at 1, right? And now I will send, and basically this, so now whenever this will read this data somewhere, it will know the logical timestamp value 1. So now when I'm replying back to it and saying, how are you, right? So I will send the logical timestamp of the previous message, which is 1, right? So now when this will receive the message, it will say, oh, the logical timestamp of previous message was 1. So I have to append it because it came after it. So it is 2, right? So now whenever I will consolidate them, I will see that this is 1, this is 2, this came after it. But if I was using physical clocks of these servers, then there could be an issue because the physical clocks of these machines are not reliable, and that has created this ordering issue.
Oh, I see that in this case, yeah, this is something. There's a special name of such timestamp.
Yeah.
Some damper or something. Let me see. I put the message in the chat. Is this kind of time you're talking about?
I don't know, probably. I don't know. It could be this. Yeah, actually happens before, right? Yeah. So it happens before relationship. So this timestamp knows that this happened before me. So I'm not 100% sure, but looks like it's similar. That my logical timestamp knows what happened before me. So that's how I'm storing storing this timestamp value. Whereas this was like just an absolute value of my machine, and I don't care about this happens before relationship, which creates these problems.
Because this can go pretty complicated.
Mm-hmm.
If we have the number C, and let's say that A have message 1 and B will follow up with message 1 and have the message 2, but C also follow up the message 1 and have another 2 plus, let's say. Then the final result will be pretty.
No, the problem will not come because so there are two important things. One is concurrent or happens before. If two requests happen concurrently, then I am free. It's the freedom of the server. I can choose whatever I want to choose first, and I can choose anyone second because they happen concurrently. So the both clients have not known that they have seen each other messages, right? So there I'm free. If I have seen A's message and now my message happens after your message, then I have to be careful that they should be properly ordered. And in that case, I will be always using this logical timestamps. So using this logical timestamp, I don't think any problem will occur. You can probably, whatever scenario you are thinking, probably you can draw it over here and we can see like if it creates problem or not.
Sure, let me share my screen.
Yeah.
Okay, the tricky thing I can see here is that I still have the time, and I have A and B and C.
Mm-hmm.
And A say that hi, this is 1, hi. And B say, how are you? So it have the previous message is 1, so this is 2. But at the same time, C sees a message, also see the hi from 1. And so it will have a 2 prime say that, what we can say?
Hello, right? He's saying hi, he's responding hello, right?
Okay, let's say hello.
Yeah.
Then how and D just a viewer. He doesn't want to say anything,
Mm-hmm.
but how he will see the message? Is it going to be the hi and how are you and hello, or hi, hello, how are you?
Both are
What
fine.
kind of
So both are fine because they both happen concurrently, right? 2 and 2 dash happen concurrently. They have not seen each other. So it will never create a problems. Like both of the chats are fine. Right?
Okay. Okay, I
Like
see
what
what
will
the
be
point.
the ID? Sorry.
Hmm?
Like we are giving this logical ordering, right? 1, 2, 3.
Yeah.
So the order will be 1, 2, 2 now, like the logical IDs will be.
Yeah.
That's
a
in
good
this
point.
case a logical ID. Yeah, we probably need to generate some ID in the database to put the order.
Yeah,
Because
I think what we can do is then database will decide if he is choosing how as the first message it will give 2 to this and hello 3 or vice versa, right?
Yeah, I think in this case, this is not only a simple database, it can be some data system that consolidate all these vector message. I have some page I put in the Zoom chat also. So this is the thing. Talking about this specifically, this is called vector clock, and it can handle the scenario that C have the message 1, and B follow up with C1 to with B1 and B2, and I have the follow up with B2, but somehow the message got messed up, and we have another message B3, and I have the B2 and I'll follow up with C1. So when they consolidate this message, they have some problem and resolve it, just like you said. So if this is the back and forth conversation, I think this makes sense.
Yeah. Yeah, so the thing that you have to do with vector clocks is you have to like in your request, you have to send what is the previous message you have seen. That is important.
Yeah.
So you have seen 1, you have also seen 1, then the server can decide like how to order the messages.
Yeah, that's right.
So yeah, I think.
And go ahead.
No. Yeah, I was saying if we are done with this part as well, then now we can go to this end-to-end design.
Yeah, sure. Is anyone else is there anyone else who have some questions for this?
One question.
Huh?
So this logical ordering will be assigned by the web server, right? Or by the DB?
I think there should be some service between the web server and yeah. In this case, I think let me draw them up.
We can have just a last sequence number or last logical number for that group chat, whether it's a peer-to-peer or group chat. We can have a last sequence number. Whenever the next message comes, we can assign that sequence number to it. That's what I was thinking, but just wanted to understand or discuss with others.
Yeah, I think the client have some responsibility to say what's the last message it sees. So when they send a message, it will say that just like client B, if we'll have the pair that 1, which is the last message, and also a new message, how are you? Something like that. And it gets this message to the web service, and web service basically does nothing. It just sends this thing directly to the database service, not only the database, but the service that will consolidate this thing into the database itself. So it may have the increased number so that this is after 1, and it can be append to the anywhere after message 1. So it may already have the message hi, and have the number 1, and it will insert it after this message, even though there could be hello already, which is 2, and if you put this message at the end of this hello, have another 2 say, maybe it will assign a different number to say that how are you. This is my understanding. So when it finishes the consolidation, it will be a line linear message rather than a vector. Does it make sense, Abhishek?
Yeah, I think when finally it's consolidated, it will be linear, because once you have shown this, or like whatever decision you have taken, let's say you have taken decision hello came first, then the database has to stick to that decision. Now it cannot again change and say that this other message came first.
That part I got it. What I'm trying to understand, like the web server will have that responsibility of assigning that whether 2 who will be assigned to hello or how are you?
Yeah, that's a good question. So now I don't have much knowledge if any databases provide this service by themselves, but generally, as far as I know, like database give this responsibility to your web server that however you want to manage, you manage. So I think web server will take this responsibility and it will just store the data in the database server. Although there could be some databases itself which could do this thing on your behalf, right? That you are sending some logical timestamp and all, and they are taking care of ordering.
Okay.
This thing is very, very important when we have multiple data nodes. So this could be, usually this is a process that we have two database nodes, some NoSQL nodes, and they have same responsibility. They are responsible for have same responsibility to handle same row of data. And so they have the red node one and red node two, and when they merge together, they need to find a way to consolidate their data. This is there are some paper for DynamoDB really talking about it, how to handle this vector clock thing. And
so do you know if the database do that merge, or so like, or like I think what I've read is that whatever are these conflict merges, it will return it to the client. And now, like, I mean client, I mean web server here. So because web server is a client for the database, so that web server will now take the decision how to consolidate them, right? So do you know that does the database consolidate, or it gives the responsibility to the web server?
I think the DynamoDB, according to the paper, it's resolved its thing, but I never see that any API can handle such thing.
Okay. Mm-hmm.
So you're saying DynamoDB handles this?
Yeah, some conflict resolution strategy.
Oh, okay, got it, okay.
Do you see that? I just see the name, but I don't see any API to do this.
Mm-hmm. Because the point is, like, how you resolve the conflict could be different based on your scenario. Like for someone, if now I change this to a collaborative editing app, then I have to merge these two values, right?
Mm-hmm.
So these two messages which came after the same time, I have to merge them and maybe combined. I have to give a combined string. Whereas in this case, I have to show them as separate messages one by one. So I think that's why databases like often try not to take this responsibility, because it will depend on your application logic, how you want to merge them. And so like probably it could be that they give this responsibility to your web application itself, but I'm not sure.
Oh, okay. Yeah. I know very little about this, honestly. Yeah, I think that's it. I think we remember we have someone raised a question before ordering. What's the question anyway? I think there's another topic we want to discuss after we finish this ordering thing.
I think we discussed, right? Like we'll have this logical ordering basically, through which even if this will maintain the order, like who sends the message first.
Yeah.
Okay, I thought that was the problem, and we are solving it by using this logical ordering concept.
Okay. Yeah.
Which is handled by the web server, or maybe some DBs handle it. So
Yeah, probably DB may need some knowledge from the application to resolve the conflict.
yes.
Yeah. Okay. Do I have any questions? If not, we think that's it, and we can talk a little bit on what we are going to talk next time.
I think Neha, you wanted end-to-end how this system will look like.
Yeah,
Right?
if we can just so that we can have a clear-cut picture like what we discuss throughout those sessions, that will be great. But yeah, we can discuss about next topic as well.
There are no next topic, and at least today we have 20 minutes, and we can talk about anything left, and we can have keep some extra a few minutes to say that what we want to talk next time.
Okay. So
Then can we just see the design, like the end-to-end design?
Abhishek, do you want to talk about this?
I don't know. Like I don't know last time what you like. I missed like
Oh,
last half hour, so I
oh,
yeah
Maybe
that
just no. Sorry. Yeah, go ahead.
that from everything from database design.
yeah. So I think people want to understand this end-to-end chat application, how this application will look end-to-end.
Okay, that's a lot.
Yeah, not like the full thing, but probably like just we discussed about notification system today, right? We can just like talk about like the how whole system design will look like between need replication or partitioning or things like that, probably.
Notification and partitioning.
No, I'm saying like the system design and then how like things will be. Do we need replication? Do we need sharding? Things like that. Can we
Oh,
see?
that is something we have last time. Yeah, let's go through that a little bit.
No, just like maybe one flow, like when let's say client A sends a message to B, the layers and those things.
Neha, if you have listened fully last time, probably do you want to give a try? Like what?
Uh, um, oh, I can give a try,
Yeah,
but like uh, few of the things might be like which I might have missed or which is just my thought. So I can share those.
yeah. That's fine. Yeah.
So okay, let me try. Okay, so
Can you keep the zoom of this whiteboard to 100%?
um, this is okay. The 100%. This Zoom.
Yeah, I think the square icon at the from the bottom to top, the second one, can reset that. The toolbar on your right side, there's a
So,
plus and minus.
okay, so the plus icon which you were clicking, right, to zoom in, go like 4 levels down, like minus, go to minus, then so second last, go to second last.
This one.
Right, you're talking about this?
Fit all content to screen.
Yeah, were you talking about this?
Yeah, is this going to reset to 100%?
Try clicking on this.
Okay, I did.
Oh,
So
that's not.
Yeah, it will just fit everything to the screen. It will not 200%.
okay. So
Yeah, I think it's fine. Yeah.
okay.
Fine.
Okay, so let me give a try. So I think yeah. To start with, let's say we have this client A, and client A wants to send message to client B. So we will have like for our chat application, we will have the web servers. So we'll have multiple web servers. So like I'm drawing the high level design. So there for our web servers, there will be a load balancer layer in front of it as well. So and for the persistence, we have the database layer. So we will store the data here. So this will be our DB. Okay, so how this would work, like let's say if A wants, like some of the things, like I would like say based on my what I have in my mind. So like let's say if A wants to send message to B, so first the request will go, and since like we discussed last time that we will be using NoSQL. So and for NoSQL, our sharding will be based on uh, let's say it's like a key range basis. So that means like users which are from A to C will be sharded to one web server. So let's say this web server is responsible for handling user A, and this web server is responsible for handling user B. So and these web servers, since it's a real-time application, chat application, so these web servers will have a will maintain a one-to-one connection with the clients which are online. So these web servers will have a uh, WebSocket connection with these clients, but which are only online. But the other clients which are offline, they will not have the connections. So so when A will send a message, this request will be from the load balancer. It will be routed to a web server A, and A A will see that this message came for client B. So it will route that request to the web server B, which is responsible for the client B, and this. Uh, but in the background, it can start a process which will store this message in DB as well for maintaining the cache history. So, but in the real time, this message, the web server B will send this message to the client B. Since this connection is already open, so it just has to push this message to the client B. And since yeah, and we will have this notification service as well. This notification service, like, so yeah, so this A, apart from storing the message in the DB, it will send this request in the our notification service as well, that we have to notify uh, B client. B client. Um, uh, yeah, so any like any questions so far, or did I miss anything important here?
I'm trying to understand that. So you want to shard the user request by the user ID?
No, I said by key ranges. So that means like what I'm saying, like if we have A to Z users, so A to some key ranges will be handled by web server A, and the next key range will be handled by the another web server.
Yeah,
So I was not part of last discussion, but I don't know why we decided this key range, because it could be a problem, right? There could be many users whose ID, like whose if it is A is a name, then whose name start with A, right? So this
I
kind
think
of partitioning might be unbalanced.
Yeah, it can be unbalanced, but there are some NoSQL DBs who does the auto sharding. So like whenever the server, if the A's data is, like its requests are too high, it will split the regions. So
But what is the advantage of this key range? Like generally, like you will store data in this manner when you want to do range queries, right? But here, like, do we need any range? Like, is the requirement was any range query? That's why we stored like this.
I thought like range queries because apart from real time, we are like in the group chat. I will see the chat history as well. So for the chat history, it will be a range query, right? So basically, for this group chat, give me the last 50 messages. So that will be a range query.
But that will that will all belong to one like one new user ID, right? So it all belongs to one. Like it won't go to every user's. Like if every user has its own. Are we saying we are storing message of every user in its like in a separate shard based on his name? If
Uh,
that's the case, then we don't know if those usernames are together, right? I mean, in my group chat, there could be one person whose user ID starts with A, other whose user ID is something like C, right? So, anyways, I would have to go to different shards.
I think that makes sense that we cannot guarantee that all the users are sending the request into a single node.
yeah.
And
So
if you have the range, that's a typical consistent hashing style. That consistent hashing have the circle that one node takes part of the ring. So that means that we have the range of the hash ID will go to one certain node.
but like maybe the example which I took was peer to peer, but last time we discussed, right, like we'll store group messages like
We already handle the group message to make the design simple, because peer-to-peer discussion is a very special group chat with only 2 users.
okay. So you are saying for this case, like our sharding best will be by user ID?
Yeah,
Or,
just by the user ID. The user ID will hash
Right?
into.
I mean, hash of user ID, right?
That's right. Hash of the user ID will map into the some ring, some
Yeah.
circle.
And by the way, so I think I need to read more about it, but consistent hashing is not used for data storage. It is used for caching. If you will read the research paper, it is like it can't be used for data storage things, and it is mainly used for caching purposes.
But Cassandra, I think Cassandra is using the consistent hashing.
So okay, okay, yeah. I think I don't know, but like in one of the book I was reading that the name is being used incorrectly. It's not consistent hashing. So yeah, if we will
But
read the
consist
Mhm.
Oh, I'm saying say the consistent hashing is trying to resolve the issue that about data migration. So if we add a new data, sorry, if we have one node overheated, we need to divide this node into 2 nodes. So we need to cut that part of the consistent hashing ID range into 2 parts. So then we can moving only, sorry, we can only move the data from only one node to another only one node. Because if we do some inconsistent hashing, so that we using the mod operation, we may the old um, old ID to hash ID mapping can really go crazy. So that we will do, if we have the inconsistent hash ID, we will inconsistent hashing the data migration will go to everywhere, takes a lot of bandwidth.
Okay.
Yeah, I think I also read that it is used for rebalancing what Hiren said.
Yeah, rebalance the data is
Data,
basically
yeah, if a new node is added, yeah.
But anyway, I think we have very few minutes, so I will call it for the day. So next time, what you guys are thinking? What kind of topic you want to talk about?
Have we discussed like logging and monitoring systems? If you want to design a logging and monitoring system, it's
Streaming thing?
no, like I mean, yeah, it's a stream. So like you have your service, you have your microservices running. So like you have your overall application which is composed of microservices. So how will you manage the log of your services? How will you monitor your service and kind of things? I think
Yeah, monitor itself, there's not really little to talk about, but design the metric streaming and actually telemetry and the logging, they are very similar.
Yeah.
So actually we can choose this topic to discuss.
Yeah. Or yeah, if someone else has any other topic, this was the topic in my mind.
We can focus on the telemetry only, because this is a very big topic.
Mm-hmm.
What about others? What do you guys think?
I'm fine with this topic.
Okay, telemetry?
Mhm.
Okay. Okay, yeah, I will call it for this, and see you next time at the same time that talk about the telemetry. And hope you guys can read some paper or some article about the streaming, because most of the time we probably will talk about that.
Okay.
That's good?
Yeah.
And
Okay.
Thank you.
yeah, one last thing, like for for the chat application, if you have any reference, like where they say that the partitioning by user ID is like better, like if you have any reference, like please do share with me.
Probably that's mostly about the database design. So
yeah, database, yeah, like if you have any reference, like feel free to share. Like happy to know more about that.
yeah, you can go to the web page of Cassandra, see that how it designed, because Cassandra is very similar to DynamoDB, which is very popular. I can send you the website of this thing, and I probably will put them into the Discord.
Sure.
Okay. Thank you. See you next time.